Okay, this time in our continued fraction lectures, this is number 3. As promised, we're going to look at the continued fraction for e. And we all know that e is approximately 2.7182812828. And to get the continued fraction, you may recall what we do is we split it up into the integral part plus the fractional part, like so. And then we rewrite the fractional part using the fact that if we have any number, a, we can rewrite it as 1 over 1 over a. So that's what we're going to do here. And now we're going to take that 1 over 0.718 and we're going to get it as we're going to go ahead and do the division. So let's go to our calculator and do that right now. Okay, there we have the approximate value of e, and notice the algorithm we're going to use here, which is what we're going to use when we put this in an Excel spreadsheet shortly. We subtract 2, the integral part, and then we simply flip the decimal part over, and we get 1.3922 approximately. Let's go back and put that in our... And now we're going to continue in the same manner. We're going to take the 1.3922, split it up into an integral part plus a fractional part, and we're going to rewrite the fractional part as a quotient, and then we're going to do the division. And again, using the calculator, the algorithm is fairly simple. We first subtract the integral part, and then we flip over the 0.39, and we get 2.5496 approximately. There we have it, and we would continue in that fashion. And let's notice something. The important numbers to remember if we want to reproduce this complex fraction are that 2, that 1, that 2, and so on. So if we can have a list of those integral values, we could then reproduce the complex fraction to whatever number of iterations we had taken it out to. We can also look at the approximation this gives us to e. Our first approximation was 2 plus 1, which was 3. Then we added the 1/2 in there, so let's see what that looks like. And working that out, we see that it's 2 2/3, or about 2.6 repeating. And we can continue to do this, but what I want to look at right now is simply the following. If we want to write all the information needed to get this continued fraction, we could say e is, and we start out with the number 2, and then we got the number 1, and then we got the integer 2 again, and we keep on going. And every time we did that, going back to our calculator, look at what we did. We took our number, 2.7 here, we subtracted the integer, and then we flipped over the fraction. Take the number, subtract the integer, flip over the fraction, and keep track of the integers. And now we're going to see how we can do that with an Excel spreadsheet. Here we go. So the first thing we're going to do, we're going to type in our number. So we're just going to type equals, and then we're going to put exp for e to the first. And we hit enter, and we get 2.718, etc. And so now what we want to do to carry out the algorithm, we need to get the integral part of this here. So we'll type into b2. We're going to type a2, which is the actual number, and we're going to subtract, we're going to type in a2, but we're going to int it, which means we're going to take off the decimal part, and that'll just give us 2. And to get the fractional part, all we have to do is subtract these. So we're going to say this equals a2 minus b2. And that gives us the fractional part of it. And what we want to do is continue with that pattern. But in order to do that, we first have to flip the fraction over. So I'm just going to call it inverse, or inverting the fraction. And so we'll put equals 1 divided by C2, which flips that over. And then we need to get the integer of that. And to get the integer of that, we come over here in the integer column and we put equals. And we're going to do int, which chops off the decimal, of this number over here, D2. And that should give us 1. And then what we want to do is get the fractional part of this one. And to do that, all we have to do is take D2, the whole thing, minus the integral part, which is B3. So that would equal D2 minus B3. And there we have the fractional part. And the same procedure continues on down from then on. We want to get the inversion of this thing here. So remember, it was 1 over C2. Now we want it 1 over C3. So if we copy down, it automatically moves that up to C3. And from now on, these 3 columns we can copy down, and we'll get each continual iteration. And there we have them. And we can see now the beginning of a pattern. We started with 2, 1, and we have 2, 1, 1, and we have 4, 1, 1. Copying down, 6, 1, 1, etc. And so we're seeing a pattern here for the number e as a continued fraction that it settles down into after the start here. We go 2, 1, 1, 4, 1, 1, 6, 1, 1, and we would expect the next would be, of course, 8, 1, 1, and so on. And it'll keep on going following that pattern forever. But of course, doing with Excel or with any piece of software, we're going to have some limit to the number of decimal places we get, which means that eventually this pattern will break down, not because it truly breaks down with the number e, but because we only have a certain degree of accuracy that we can achieve. So that's how we can set this up with working with Excel. And now we can do it for any number. Let's just try it here with pi. So we type here equals pi, parentheses, parentheses. That's how you do it with this. And there we have the continued fraction integers for pi. We can do this with any number now. Square root of 2, sqrt, 2. I believe this is one we did in an earlier lesson. And I forgot to put the equal sign, and if you do that, you're going to get an error. So we have to put the equals, and we hit enter. And the square root of 2, I believe we got this before, just as a continuous list of 2's as you go down. So doing this, using this spreadsheet, we can get to a certain degree of accuracy, depending on the limit of the accuracy of our spreadsheet, in number of decimal places it'll give us for numbers, or the number of significant figures it'll give us. We can get any continued fraction form. And the next thing we'll do in the next lesson is we'll show how we can alter this spreadsheet so that we can get not only the continued fraction, but we can get the rational number associated with that continued fraction. For instance, when we did pi, we've got 22 sevenths and so on. But we're going to see if we can get those numerators and denominators as we go further and further down. So that's all for lesson 3. Lesson 4, we'll do a little bit more with this Excel spreadsheet.